Hey, all you Grimace fans. Me, myself, I'm a Hamburglar fan, but I apologize. We're going to talk today about integrals. Let's do that. Integrals involving trig substitution. Now, these don't seem like they would involve trigonometry, but they do. All right. I'm going to show you an example with this one first, and then I'm just going to show you the trig substitutions for these second two. Not doing an example, but we'll talk a lot about it in class. So these are the forms. So let's take a look at the first form. I've already got it worked out for us, so I'll try to explain as we go. So here we go. Here's the first one, the square root of 9 minus x squared, which you can see if a equals 3, this is a squared minus x squared. So it follows that form. Now what we're going to do is we're going to let x equal 3 sine of theta. Okay, and some of this work I'll come back to. But if x equals 3 sine theta, then dx equals 3 cosine theta d theta. So notice what I've done is 9 stays 9, x becomes 9 sine squared theta, and dx is replaced by 3 cosine theta d theta. All right, so I've completely replaced the x's, excuse me, with thetas. All right, and so now I'm going to come here and I'm going to factor out those 9's right here. So I have 1 minus the sine squared theta. Okay, and so notice that the square root of 9 here, the square root of 9 is 3. And so what I'm going to do is I'm going to take that 3 here and this 3 here. 3 times 3 is 9, and that becomes this 9 here. Now, 1 minus sine squared theta we know to be cosine squared theta. Okay, so this is the integral that I have left. I've pushed the 9 outside. I have the square root of cosine squared, and this cosine theta is still that cosine theta there. Okay, now if I take the square root of cosine theta times cosine theta, we should get cosine squared of theta, right? And so the 9 stays the 9, and the d theta stays the d theta. Now, the only way we know how to integrate cosine squared of theta is to change it, like we learned in last section, to 1/2 plus 1/2 cosine of 2 theta. All right, and so then when we integrate that, a half becomes a half theta when we integrate. And this 2 theta right here makes us divide by 2. A half divided by 2 is this 1/4 here, and the integral of cosine theta is sine theta. Okay, so now we're going to distribute. Let's distribute the 9. So we get 9 halves theta plus 9/4 times. Now I'm going to change this sine of 2 theta into 2 sine of theta cosine theta. I probably shouldn't have made all these marks ahead of time, but I did as I worked it out because I was talking in my head. Right? And so then, okay, let's go right here. 9/4 times 2 is 9/2. Okay, now if we come back up here, remember that sine x equals 3 sine theta, and so therefore sine of theta equals x/3. So let me explain this triangle here. If let me try to get them both in the same screen. Sine is x/3. So here's a right triangle. Sine of theta equals x/3. And if we complete the Pythagorean theorem, we get the square root of 9 minus x squared. Okay, so let me come here. Sine of theta is x/3. Right here, sine of theta x/3. Cosine theta is the square root of 9 minus x squared over 3. Okay, so that goes right here. All right, and then if I simplify that, cross out to the 3's, because 3 times 3 is 9, and so this expression is that right there. Now, notice, let's come back here to theta. All right, let me come back over here. Sine of theta equals x/3, so theta equals sine inverse of x/3. So if we come back down here, theta, notice I've replaced with sine inverse of x over 3. And so we get 9/2 times sine inverse of x over 3. And so if I put all of that together, this is my solution. All right, I went through that kind of quick because I had it all written out already. So if that doesn't make sense, please ask in class, pause the video, rewind it, whatever you need to do. Okay, now I'm not going to do any other examples just because I think it bogs down in a video, and so we'll talk about it in class. But the next two, if we have a squared plus x squared in an integral, wow, excuse me, we substitute with a tangent theta, and so then dx equals, as you should know, a secant squared of theta. Right, and then if we have the square root of x squared minus a squared, right, x equals a secant of theta, and dx equals a secant theta tangent theta. And hopefully it'll become a little more obvious in class why we're going to make those substitutions, okay? But those are the substitutions that are going to help us simplify and actually do these integrals as well. All right, hey guys, thank you for watching. I appreciate you taking the time to do so. We'll see you in class.